lesson 2 for Algebra 1, and we're evaluating and combining like terms. Basically, in this lesson, we're going to cover 3 topics: evaluating expressions and equations, combining like terms, and distributing. So first, we're just going to jump right in, and we're going to tackle these problems. So essentially what we're doing here in this first lesson is we're answering how do I evaluate expressions? That's the first question we have. Atrocious handwriting I have. Okay? So when you substitute, you're just replacing a variable with a number in an expression. Now, variables are symbols that replace a number in an expression, equation, or inequality. Coefficients, that's the number. So variables, examples of variables, x, m, n, g, these are all variables. Coefficients are numbers in front of an expression. So the 2 and 2x, the 2 is a coefficient. This is my coefficient. For -3m, -3 is my coefficient. Okay, it's just a number in front of a variable. A number that is added or subtracted in an expression, equation, or inequality is a constant. So if I said 2x plus 2, this number is a constant. If I said 3x minus 4, -4 is a constant. It does not have a variable added or, multiplied by it. For expressions are just mathematical phrases. There is no equality, or in this case, or inequality symbol. Okay? Now, for equations, let's go down a little bit here. So apologize, my bad. Let me go back up. So for equations, it's a mathematical sentence that states that 2 expressions are equivalent to each other. So an example would be 2x equals 3x plus 5. On the other hand, an expression is just 2x. 2x is just an expression, or 3x plus 5. It's either or. It's not both. Now, a mathematical sentence that states that 2 expressions are not equivalent to each other is an inequality. So 2x is less than 3x plus 5. It can be greater than. Regardless, because of the symbol, it's not an equality. Now, how do I substitute? Well, first, replace each variable with the given value using parentheses. Use the order of operations to solve the expression that you're left with. Okay? So first, z. I'm going to rewrite this. I'm going to rewrite it so it's bigger. Z minus z. So 7, z equals 7. Nope, z equals 3. So 3 minus 3 equals 0. Here's my final answer. Another example. U equals -1. So below u, I'm going to put -1 plus 2 times what's y? It's 9. So I'm going to multiply first. 2 times 9 equals 18 plus -1. -1 plus 18 is 17. Here's my final answer. Now, next problem, z minus 2x. So 3 minus 2 times 7 equals 3 minus 14 equals negative 11. Last one, I have negative 2, square, hard bracket, 4 times 7 minus 6 times 3, close parentheses, close hard bracket, plus 3, divided by, u is negative 1, minus 9 times 3, plus x is 7, minus y is 9. And then after that, we're going to use the order of operations. So I'm going to be doing things a little bit different probably than you're used to. But just try to follow along. Play back the video if you need to. So let me push this up a little bit here. Okay. There you go. All right. So looking at the top part, I'm going to do this first. So negative 2, hard bracket, 4 times 7 is 28, minus 6 times 3 is 18, plus 3, divided by negative 1, negative 9 times 3 is negative 27, plus 7 minus 9 is negative 2. Okay? Now, put my equal sign out front. I'm going to press do equals again. And then next, I'm going to do what's inside of this hard brackets on the top. So negative 2, hard bracket, 28 minus 18 is 10, plus 3. Then on the bottom, negative 1 minus 27 is negative 28, minus 2. Then on the bottom, I'm going to say negative 2 times 10 is negative 20, plus 3, divided by negative 30. Simplifying, I get negative 18 over negative 30. A negative divided by a negative becomes positive. When I simplify 18 over 30, I can take out, I can say 18 divided by 6, and I get 3 at the top. 30 divided by 6, and I get 5 at the bottom. Simplified, I get 3/5. Now, the next part, we're going to evaluate formulas. I'm going to do number 1 and 2, and you're going to do number 3 on your own. Okay? So we're evaluating in these formulas. That means for this first one, it says V equals 4/3 pi r cubed when r equals 7. So we're going to find V. We're going to find V when r equals 7. So V equals 4/3 pi, and that r cubed, I'm going to put parentheses. Inside, I'm going to substitute, in place of r, I'm going to substitute 7. So this equals 4/3 pi times 343. Now, doing the math, you get 343 times 4 equals 1372 pi divided by 3. And this is your final answer when you substitute 7 into r. For number 2, you're looking for area. Area equals 1/2 times the quantity of B1 plus B2, B sub 2, times H. When B sub 1 equals 6 and B sub 2 equals 3 and H equals 3/4, we're going to find the area. Okay? So area equals, I'm going to just substitute everything in, right? So here, B1, B sub 1 is 6, B sub 2 is 3. The height is, or H is 3/4. So I'll do some quick math here. I have 1/2 times 9 times 3/4. That's going to give me an answer of 27/8. Final answer. I'll let you solve for I and the third one on your own. So in summary, to substitute or evaluate, you're just replacing a variable with a number that it equals. The next section, the next part of this is combining like terms. We're going to combine like terms. So like terms are terms that have, the same variable and the same power. So if I have an x term, I need another x term. If I have an x squared term, I need another x squared term. So that means 2a's and 2b's, that means it's 2a, and 3a are like terms because the variables are the same. Now, 2a and 3b are not like terms because the variables are different. Because variables are different. Now, if I have 2a and 3a squared, these are not the same. These are not like terms because while variables have different powers. The first has a power of 1. The second one, 3a squared, has a power of 2. So we need to combine like terms to simplify expressions. We cannot combine two different variables. We cannot combine variables where the powers are different. The next part, we're going to learn how to use algebra tiles. Okay? So to write expressions for algebra tiles, we identify the tile types and add the like types together. So first we're going to name the collection. I have 3 x tiles, and I have 4 1s. So I'm going to name this collection. I'm going to write 3 x's plus 4. Or you could say x plus x plus x. That's 3 x's. 1 plus 1 plus 1 plus 1 is 4. In the next one, I have x plus x. So 2 x's and easy peasy 4 1s. All right. In general, that's 2x plus 4. Okay. The last one, I have 1x squared tile. I have 5 x's. I have 6 1s. Okay. So I have x squared plus 5x plus 6.
Attention Wolverine Nation, I know everyone is excited for the 3-day weekend, but...
So we're going to go through some examples of combining like terms. So first, look at the first problem. It says 3x's plus 4x's. Well, ask yourself, are these the same variables? Well, I have an x and an x. Do they have the same power? Yes, they do. So I can combine them. If I combine 3 and 4, I get 7 x's in all. And you're done. Now, what happens when you don't have all like terms? So since 4h and negative 2h are like terms, you can combine them. Since the 7 um, exists, since the 7 exists, you cannot combine it. It's a lone number. It's a lone number. It does not have a like term. It does not have a like term. And you must place it on the end of the expression. So for me, I like to circle my like terms and then combine them. 4h's minus 2h's is 2h plus 7. Recording video. Yeah. Okay. So in the next one, what I want you to do is to kind of identify like terms. You can highlight them, and I'll show you what I mean. It's easier if you highlight your like terms. They're easier to see. So look at number 3. What two terms are like terms? Well, first of all, since negative 3x and 7x are like terms, you can combine them. So I'm going to highlight negative 3. These are like terms. Now, 3y does not have a like term, so I'm just going to make it green. However, negative 5 and negative 4 go together. So I can combine those two things. So at the end, I should have an x term. Then I should have a y term. And then a number term. A term with numbers only. Okay? So I'm going to go ahead and do this. Negative 3 plus 7x. I'm going to get, if I think about it, negative 4x. Okay? Now, for my y terms, it's just the y it's by itself, so it just comes down. It retains its identity. 3y. And for my numbers, minus 9. So basically, essentially is a more appropriate word. What happens? For negative 5 and negative 4, they're also like terms and you can combine them, which is what we did. Okay? The 3y stays the same. So, number 4. We're going to do the multiplication first. It's a great segue into the distributive property. So 8a minus 2a minus the quantity of minus 2 times the quantity of a minus 7. So distributing first, I have 8a's minus 2a's plus 14. Maybe you don't know how to do the distributive property, but we're going to do it pretty soon. Next, I'm going to combine like terms. My like terms are 8a's and negative 2a's, and 14 is just a lone number. So 8a's minus 2a and 14 stands alone and cannot be combined because it does not have a like term. So 8a minus 2a plus 14 is what we got before. Combining 8a and 2a, we get 6a's plus 14 as a final answer. Okay? If that was confusing for you, play it back. And also just come touch base with me. The next part we're going to work on is the distributive property. So the essential question is how do I use the distributive property? Well, you could use it across addition. You could use it across subtraction. And this is just multiplication. I like to use a dot for multiplication. Now, if you look at the bottom two, the distributive property, this is new for Algebra 1. The distributive property can be used in division across addition. And we're doing something called the butterfly technique here. You see, this simplifies to A divided by C plus B divided by C. And for over subtraction, something similar happens. Okay? Now, there are three methods to distributing multiplication algebraically. One method should remind you of two-digit multiplication. Okay? So what does this look like, Miss Smith? Well, I come here and I write x plus 3. Well, let me give you an example. So let's say your teacher told you to multiply 25 and 3 times 25. Well, before, when you did two-digit multiplication, you may have rearranged it, put the big number on top and a smaller number on the bottom, the one-digit number on the bottom. And then just went from side to side. 5 times 3 is 15, carry the 1 over, and I get 75, right? 2 times 3, 6. 6 plus 1 is 75. Well, with this method, you're doing something similar. So your big part is x plus 3. The smaller one-digit part is 4. So you're going to say x plus 3 times 4. And 3 times 4 is 12, plus 4 times x is just 4x. Super simple, very useful in units later on, okay, in our polynomials units. Now, what about 2 times the quantity of x squared minus x? You can do the same thing. X squared minus x times 2. X times negative x times 2 is negative 2x. X squared times 2 is 2x squared. Remember, the number comes first. So your final answer here is 2x squared minus 2x's. Now the second method is worked in a box. So you're going to say, for this method, you're going to say negative 6, have your box. Let's make some room here. So create your box. And above that box, we're going to put 4 and then negative x. And we're going to multiply 6 by each of the terms inside of that parentheses. So 6 times 4 is 24. 6 times negative 6, remember the number comes first, so minus 6x's. Okay, so your final answer here is 24 minus 6x's. On the next one, still got the box, biggest term on top, have w and 2, and then a 5 out to the side. 5 times w is 5w, 5 times 2 is 10. Putting those together, they're both positive. I get 5w's plus 10. The third method is worked from side to side. I get negative 4 times x plus, sorry, that's a negative in front of that 4, Negative 4 times 5 equals negative 4x minus 20. Next problem, side to side, equals x squared times negative 7 minus x times negative 7. Simplified, I get negative 7x squared plus 7x. Final answer. So, summary of this, summary of these notes. We're not quite ready there. Sorry. I got ahead of myself a little bit. Now, how do I use the distributive property through division? There are 3 methods to use the distributive property of division algebraically. The first method should remind you of long division. Long division. So you have 2. Sorry. You have 2, the root looking thing, 6x plus 8. And you just divide each term inside by 2. So 6 divided by 2 is 3, and the x is left over. Plus sign comes up. 8 divided by 2 is 4. Here's your answer. This equals 3x plus 4. The second problem, same thing. 3 goes outside. The little root thing goes here. 12 minus 9x. 12 divided by 3 is 4 minus 3x. Okay, so if you didn't catch that last part, a little bit like scribble scratch there, but just redoing it. 3 root 12 minus 9x. 12 divided by 3 is 4. Negative 9 divided by 3 is negative 3, and your x just comes up. So your final answer here is 4 minus 3x. The second method used is the box method. So you're moving backwards. Instead of above, this part here is just going inside. So negative 4 inside of the box. And we're looking for the parts that come back out. So x minus 4. Well, x divided by negative 4, there's no term, there's no number really that I can divide this by except for 1. So I have x over 4 over negative 4, and then negative 4 over negative 4. Simplified, that equals 1. So my final answer here, I'm going to put it out to the side, negative x over 4 plus 1. On the other hand, I have 16 over c. So c, put it in my box. We're using the box method. 16 and negative c. So I get 16 over c. I got ahead of myself. 16 divided by c is part of my answer. And then negative c divided by c. So I can't simplify 16 over c anymore. It's just going to be 16 over c minus c divided by c is 1. Here's my final answer. The last method is my favorite. I think it's the easiest and most intuitive method ever. But that's just me. Everybody has a preference. It's the butterfly method. It's where you use the number in the denominator and you just divide it by each term. You divide it by each term. That means you get butterfly here, negative 5x divided by 5, and then plus 25 divided by 5. Essentially what I said, divide each term in the numerator by the term in the denominator. And you get negative x plus 5 as an answer. So much easier. And then for the second one, 2x minus 8 becomes 2x divided by 4 minus 8 divided by 4. You get 1 half x minus 2. Final answer. Okay? So there are three methods. To distribute. The reason we showed you 3 for multiplication and division is, put a little semicolon there, you need, or in your case, I need to pick one. All right, guys. I enjoy your time and your company. I hope that your day goes swell. I will pick up next class with lesson 3, exponents, truth, and graphing. Have a good day.